In this problem, we are given a function f of x, and they are asking us to find the nth derivative at 0. Okay? So one way to approach this type of problems is to use power series technique. So we use power series technique. The center here will be given by the number that we have here. So in this case, for example, is 0, but it can be 1, it can be any number, okay? And then once we have f of x equal sigma of an xn from 0 to infinity. So this is the power series. We found the power series. So we know that the nth derivative from the Taylor formula, Taylor series, is equal to an. So if you are looking for the derivative of f, so in other words, we know the coefficients an from the power series technique. So this will be n factorial times an. That's the formula. Okay? So here, the function given to us is f of x equal x cubed e minus x squared minus sine of x cubed. So the functions that generate this function f of x are sine of x, for which we know the power series. It's x minus x cubed over 3 factorial, x5 over 5 factorial, etc. And we know that the radius of convergence is plus infinity. And then we need ex, which is 1 plus x, x squared over 2 factorial, x3 over 3 factorial, etc. So these are the two functions, and both of them are lucky they have an infinite radius of convergence. So in this case, we have to go one by one. So we have to use the techniques of power series. So first of all, we need sine of x cubed. Okay, so we get sine of x cubed is equal. So here you plug in x cubed into x, and you will get x cubed minus x cubed cubed x9 over 3 factorial, x cubed to the fifth plus x15 over 5 factorial, etc. Okay? And for e, we have e to the power minus x squared. So we have e minus x squared equal 1 minus x squared squared plus x4, 2 factorial, minus x squared cubed minus x to the power 6 over 3 factorial, etc. And then we multiply by x cubed. So here will give me x cubed e minus x squared equal x cubed minus x cubed times x squared. We add the powers, 5. X cubed times x to the power 4, we add again the powers, 7. X to the power 9 over 3 factorial. And then we have a problem. Why? Because the question is to find the 11th derivative. They asked us for the 9th derivative, then we have no problem. But they ask us to find the 9th derivative and the 11th derivative. So now, what happened here is crucial. We have to go all the way to the 11th. And for that, no panic, because we look at sine. Sine, we are already at 15, so we are safe. Okay, the 11th has to be between x9 and x to the 11th. So here what we do, we go back and we add one term. Okay, so I'm going to add it in a different color. Sine of ex, so we are going to add x to the fourth over 4 factorial. Okay, see if it's enough. So now we have e minus x squared, so it's going to be x to the power 8, because it's x squared to the fourth over 4 factorial. And since we multiply by x3, it's going to give me x to the power 11 over 4 factorial. That was the term that was missing. So no problem, we can even add more terms if we wanted, okay? So now if I put everything together, my function f of x will be, so it's x cubed e minus x squared minus sine of x cubed, and putting all the stuff together, I'll find, so the is equal to the part for x cubed minus x5 plus x7 minus x9 plus x11 over 5 factorial, etc. That's for the x cubed e minus x squared minus, and then we have to add the sign of x cubed, which we just found right here. So it's x cubed minus x9 over 3 factorial x15 over 5 factorial, etc. So if I put the algebra together, I will find that f of x equal x cubed minus x cubed is gone. We have minus x to the fifth, that's the first one. And then we have x7 plus x7 over 2 factorial. And then we have the ninth here. So we have minus x9 over 3 factorial minus minus is plus x9 over 3 factorial. So it's 0. It cancels. And then we have plus x11 over 4 factorial. And that's it. That's the only term we have in the 11th because the sign x cubed does not have an x to the power 11. So here, since we do not have, so we know that this is equal to 9 factorial a9, but a9 is 0 because there is no x to the power 9, so this is 0. And for the f11 at 0, so we're going to find 11 factorial e11, and a11 is the number we have in front of x to the power 11. So it's 11 factorial over 4 factorial.